So I expect this. I expect that today's class won't be that long. We'll be talking about the specs of the project number one. So this is the first project, and yeah, I am going to upload this on Classroom after the class, or actually I can upload this right now, but yeah, I'm not sure if anyone who didn't attend today's class can actually just read this and then follow the specs and and do the project number one on their own. So yeah, I was hoping a lot more would come so that I don't have to answer questions on Classroom individually. But I guess that's fine. All right, so we've decided that the project number one would be ICU Mortality Prediction. So far we've for over the last several classes we've looked at we've used the example of ICU readmission prediction or the hospital readmission prediction, but this is ICU mortality prediction, so it's a bit slightly different, but overall it's more or less the same. You just the prediction task is based on a single ICU admission, and that's it. So if you remember, ICU readmission prediction was also based on a single ICU admission, and the target was to predict whether the patient would be admitted to the ICU again within the same hospital stay, within the blue strip. Unlike that, so this is based on a single red strip being the ICU stay. So based on a single ICU stay, the red strip, we're trying to predict whether the patient would die or not within that red strip. So we don't have to look, outside the red strip. So it's a bit more simple. It's a bit more straightforward when you pre-process the data. You don't have to think about what happens outside the red strip. So that's it. Oh, by the way, if you have any question while you're going through the specs, please let me know, or you can just type in the chat box, or actually use your voice. So objective. So it's a bit long. So we'll go through the specs one by one section at a time. And it is long because we were trying to, the TAs and I were trying to make it as detailed as possible so that there are minimal confusion. All right, so the objective is given ICU records where the length of stay is between 24 hours and 48 hours. So this is important. So we are only interested in patients whose length of stay is between 24 hours and 48 hours. So how do you know length of stay? I hope that everybody remembers where to look at or where to look for to figure out the length of stay. So let me right. So this is the ICU table. So there are a lot of tables in Mimic3, and there is specifically a table called ICU stays. And if you go here, one of the columns is named LOS, which is length of stay. So length of stay being length of stay for the patient who has, for the given ICU stay, which may include one or more ICUs. So the length of stay is measured in fractional days. So it's if it's 2.5, then it means that it's 2.5 days. So that's where you need to look for. Right. So we're only interested in patient who has stayed in the hospital, in the ICU, not the hospital, in the ICU, individual ICU, between 1 day and 2 days. This is actually one. And use the information from the first 3 hours, to predict whether the patient would die during the ICU stay. So you are filtering out patients so you're only selecting the patients who stayed in the ICU between 24 hours and 40 hours. And once you've chosen your target group, your target patients, you will use the first 3 hours after the admission to the ICU. So after the patient has entered the ICU, you are only using the first 3 hours amount of information to make a prediction. So that's it. And the prediction would be whether the patient would die within the hospital or not. So you're looking far, you're trying to predict events that are far into the future, because if the patient stay within 24 hours and 48 hours, it means what if the patient died, then that patient would have died between 24 hours and 84 hours. But you're only using first 3 hours. So you're using very small amount of information in the very, very early phase to predict something that happens after several hours. So it's a bit of a challenging task. All right, there's a question. I downloaded the data, so I only have that. Should I use only the? Yeah, so I only have. No, we'll get to that. We'll get to that. Don't worry about that. Oh, by the way, actually, I should have maybe asked whether. Okay, we have 43 people. 첫 세션 정보로 다시는 밀 수 있는 리눅스에서 구분이 가능해지는가요? 네, 구분이 가능합니다. 그러니까 이제 ICU에 딱 들어온 순간부터 3시간 이내에 발생한 정보만 사용하라는 거예요. 근데 이제 언제 ICU에 들어왔는지를 다 알 수가 있습니다. 바로 여기 ICU 스테이 테이블에 가보면은 인타임이라고 있죠. 인타임을 보시면 이 사람이 언제 들어왔는지 알 수 있거든요. 이 사람이 들어온 시점부터 3시간 이내에 발생한 정보만 사용을 하는 겁니다. 이제 그것도 이제 제가 차근차근 가볼게요. 안성용님. 그렇죠. 맞습니다. 근데 121 기간 동안 사망할지 안 할지가 아니라 애초에 121 기간 동안 그 사이에 죽었거나 아니면 그 사이에 이 상태가 나아져서 ICU에서 빠져나왔거나 어쨌든 이 길이는 이틀 넘지 않아야 돼요. 그러니까 하루를 넘고 이틀 넘지 않아요. 죽거나 사나 어쨌든 이 스테이한 기간이 하루에서 이틀 사이여야 됩니다. 그래야지 이제 이게 쉽잖아요. 이게 쉬운 게 아니라 그래야지 이게 공평하잖아요. 예측하는 게. 네, 그래서 그렇습니다. 그러니까 애초에 그냥 우리는 그러니까 3일 이틀 이상 3일 동안 ICU에 스테이한 사람은 애초에 그냥 필터 아웃 해버리는 거예요. 우리의 그 데이터 트레이닝 셋에 들어가지도 않습니다. 아니면 예를 들어서 18시간만 스테이한 사람도 빼버리는 거예요. 네, 애초에 그 사람도 우리의 예측 대상이 아닌 거예요. 우리의 예측 대상은 하루에서 이틀 사이에 스테이한 사람만 이제 예측 대상입니다. 네. 그리고 진행하기 전에, so yeah, before we further proceed, how many of you among the 43 attendants today, how many of you do not have access to Mimic 3 yet? 그러니까 아직 미믹 3를 다운을 못 받으신 분이 계신가요? 오늘 여기 오신 43명 학생분들 중에? 네, 그럼 오늘 여기는 없는 걸로 알겠습니다. 그럼 대부분 다 있으시고 아마 한두 분 정도가 지금 문제가 되는 것 같네요. 네, 알겠습니다. 그리고 이제 안성용님 질문이 그럼 필터링된 대상 인원에도 3시간 내의 정보만을 사용해도 사망 여부 필터링된. 그렇습니다. 그러니까 네, 1시간 이 하루에서 이틀 사이의 LOS 그러니까 length of stay를 가진 사람들만 뽑아서 그 사람들 가지고 3시간 내의 정보만을 사용하는 거 맞습니다. 그거예요. 첫 3시간 이내 사망 경우 포함할 수가 없습니다. 왜냐면은 지금 하루에서 이틀 사이 동안 무조건 있어야 돼요. ICU에. 그 말은 죽어도 그 사이에 죽어야 된다는 얘기입니다. 보민님. 규현님, 저 아직 다운받지 못했습니다. 왜 다운받지? 혹시 아직도 승인을 안 해줬나요? MIT 쪽에서? 그럼 언제든 다운받으실 수 있는 거네요. 네, 그건 그럼 하시면 되고요. 네, 그러니까 아직 승인을 받지 못하신 분 계신가요? 네, 저한테 개별적으로 한두 분 정도가 이제 승인을 받지 못했다. 열흘 정도 됐는데 아직도 승인이 안 났다 이런 얘기가 있었는데 혹시 그게 흔한 경우인가 궁금해서 그러거든요. 네, 그럼 그런 분 없는 걸로 알고 진행하겠습니다. Alright, so we'll proceed. And this is good. So if you have questions, you can just write them on the chat box. So this is the setup. We'll go through the details one by one, so don't worry about the details. The objective also is to use logistic regression, a binary classifier, and gated recurrent unit, GRU. Also, it should be used for binary classification. So we will use both classifiers to compare performance, so whether this is better or this is better. Hopefully, GRU would show better performance, but it's not always the case. So, and the data set is obviously you will use mimicry and tables and features. So what kind of tables should we use and what kind of features should we use? So we'll go through that. This is the section that talks about that, the information. So each patient has one or more ICU. So each patient, this is important, each patient has one or more ICU admission records. So that means within a single blue strip, there could be many red strips, as we said. And where each ICU admission has a unique unique ID denoted by ICU stay ID. So if you go to ICU stays table, there is ICU stay ID, right? So a single red strip would generate a single ICU stay ID. So it doesn't matter whether it's from the same patient or not. So if the patient makes multiple visits to the ICU within the same blue strip, that means multiple unique ICU stay IDs will be generated. And use the following columns from each table to form a patient representation vector. So you want to, obviously you want to, obtain or derive a patient representation vector so that you can push them into logistic regression or you can feed them into GRU. It is important that you must use chart time to form. So we'll get through this first. So the one thing that you must use, one table that you must use is chart events. So to start in the chart events, let's go to chart events actually. So ICU stays table would be used to select who are eligible to become our training set or our data set. So the people whose LOS is between 1 and 2, they are eligible. And then you have the in time and out time. You have ICU stay ID. So you have meta information here that must be used to select who will be eligible. And then if you go to chart events, chart events has a lot of columns, but all you need to know is there are ICU stay ID, and then there is chart time, then there's item ID, and then there's value number. So those are the ones that you need. So ICU stay ID. So you must, when you go through the chart events, you must know each chart from which ICU stay ID came the chart event entry. So a single chart event entry it comes from a certain ICU stay, and it has item ID. So if it's blood pressure, if the event is about blood pressure, or if it's blood pressure, if it's about respiratory rate, if it's about the a heart rate, if it's about like which event is measured is decided by the item ID, and from which ICU stay came this information is decided by this ICU stay ID. And then chart time is when that information was charted, when that information was measured, when the blood pressure was measured, when the heart rate was measured. So that's chart time. And the value, so are we using, so value num. So there's value num, and they are supposed to store the same information, but value num is it's stored in the number format. So it's stored in the float type, and value is stored in string type. So you should use value num. So like the blood pressure being like 120, or body temperature being 36.5, something like this. So like that value in the number format is stored in this column. So you should use ICU stay ID, item ID, value number, and chart time. And you must use chart time. You must use chart time to form a sequence of events within the first 3 hours. So our target is to use information that occurred within the first 3 hours, and you must use chart time to sort the events by the temporal order so that you can feed them into the RNN, into the GRU. All right. And item ID. So the item IDs are just a bunch of numbers. So they're a bunch of numbers. But if you wonder what kind of information or what kind of event each number represents, then you can go to D items. You can go to D items, and look for what they mean. So there are item ID, and then there's labels. So you can look at the labels to see what they mean. Actually, maybe we can go through a couple examples. Okay, so this is where my bunch of CSV tables are located, and you can, if you look at chart events, yeah, there is no way you can. I mean, loading the entire chart events would take a lot of time because, as I said, chart events has about 300 million rows, like 3억 ro인가? 하여튼 몇 억 ro가 있기 때문에 그거를 다 로딩한 건 한 번에 로딩한 건 어렵고요. 어쨌든 저는 이제 끊었습니다. 컨트롤 C로. 그래서 so yeah, if you look at the item IDs here, then this is 1, 2, 3, 4, 5. So it's the fifth column. So 1, 2, 3, 4, 5. So this is the fifth column. So 2, 2, 3, 8, 3, 4. And if you wonder what they mean, so obviously it has number value 15, and the unit of measurement is liter per minute, but we won't be using this anyway. So anyway, so this is value number 15, and let's see what they mean in the D items. Oh, let me copy this again. 2, 2, 3, 3, 4. That means O2 flow. So that O2 flow, I guess it measures. What would it be? So it's obviously it's measuring the flow of an oxygen. So that is probably why it's called liter per minute. So it's a rate, but I'm not sure why this is measured. Anyway, so if you wonder, if you're interested in what individual item IDs mean, then you can always refer to ditems.csv and then look for and capture their semantic meaning. All right. So back to the back to the specs. So all right. So this is the minimum requirement. You must use chart events and these 4 columns to form a sequence of events so that you can push them into the RNN. And feel free to use other tables or additional features. So like this is the minimum requirement, but you can use gender information from the patient's table. So if you go to patient's table, there is gender information. So if you're interested in using gender feature to actually, to get better performance, then that is also totally okay. You can use ethnicity information from admissions table. So admissions table, there is ethnicity. There's ethnicity, there's marital status, there's religion, language, insurance. There's a lot of meta information as well. So you can use those information somehow to get better performance, to build a better classifier. Maybe like, death of a patient is affected by gender or ethnicity or something like that. I mean, it's an assumption, it's a conjecture. So you might want to try out different stuff. But the important thing is not to use features that are outside the first 3 hours. So that means that in like language, religion, marital status, or gender, ethnicity, those are okay because they don't change over time, But you must take care not to use information that are outside the first 3 hours. For example, you might wonder whether it's okay to use diagnosis codes as a feature. So you might go to diagnosis ICD, and use the ICD-9 codes as feature, but that is not okay because diagnosis codes are given to the patient at the end of the hospital visit, at the end of the blue strip. So that is outside the 3-hour range that is allowed to us. So you must be really careful not to use information that might leak the future. You might not to use features that might leak information from the future. So that's like cheating. So please be careful. So the question. 이번 프로젝트 스파크를 써야 하나요? 전 처리 시 컴퓨터 코스 많이 오는 양지. 스파크를 쓰면은 좋은데요. 스파크를 안 써도 할만합니다. 이 차트 이벤트가 3억 로우인데 이거 라인 바이 라인 읽어가면서 이제 전처리를 하면은 이거 뭐 한 몇 시간이면 할 수 있거든요. 그래서 스파크를 쓰면 훨씬 빨리 되겠지만 그렇지 않아도 그냥 코드 짜놓고 돌리기만 하면은 뭐 이게 뭐 무한정 걸리는 건 아니기 때문에 충분히 할 만합니다. Question from Sorrow: Shall we discard the data with ICU stay less than 3 hours? ICU stay time to our I'm not sure what you mean by that question. So the steps were that the steps were to discard patients or actually discard ICU stays whose LOS is less than 1 day or more than 2 days. So we're only interested in ICU stays whose LOS is between 24 hours and 48 hours. So anything other than that, you should discard. And then once you've chosen your target, then you use information that occurred within the first 3 hours of the admission. Hope that makes it clear. All right, cool. All right, and another thing is keep SQL 쓴 걸 다운받을 수 있나? SQL 쓴 거를 아니, 그 온라인에서 SQL 쓰는 거는 그냥 쿼리로 끝나는 거고 그걸 다운받는 거는 복붙을 하지 않는 이상은 네, 안 될 겁니다. 당연히 잘 모르겠네. 아마 될 수도 있을 것 같은데 그건 제가 시도해 본 적이 없어서 모르겠습니다. 왜냐하면은 그 SQL은 피지오넷 아이디가 있는 사람은 쓸 수 있거든요. 그 말은 이제 이미 CT 트레이닝 다 끝나고 이미 이걸 다운받을 수 있는 사람만이 SQL 그 익스플로러도 쓸 수 있는 거래 가지고 어쩌면 뭐 다운받을 수 있는 옵션이 있을지도 모르겠는데 근데 아마 쉽지 않을 거예요. 그 애초에 SQL로 하는 것 이거는 네. 뭐 시도를 해 보시는 것도 좋을 것 같습니다. 되면은 뭐 클래스홈 같은 데 올려서 알려 주세요. Alright, all right. So another important thing is keep the maximum sequence length of each sample to 100. So we are only extracting information from the chart events. We are only extracting events that happened within the first 3 hours, but that might be already too long. So there might be like hundreds of events that occurred within the first 3 hours. Like, for some patient who are really critically ill or something, or who's really in a severe state, then immediately after the admission to the ICU, a lot of things might happen. Well, I mean, it's unlikely, but it is a possibility. So once you've extracted events from the chart events for the first 3 hours, and if it happens to be that the sequence length is more than 100, then please just cut them out. So this is to make the RNN training more manageable. So we don't want to have like 300 or 400 length sequence of like events. So that would really take a lot of time to train the RNN. So to make everything simple, please just keep the maximum length of each sample into 100. And if some ICU stay has more than 100 events within the first 3 hours, remove the extra events to keep things short and simple. All right, so things to consider. So continuous values. So because these are continuous values, more or less. So each discrete item ID comes with a continuous value. How would you use these two types of information to form a sequence input? So it is not enough to just, it is not enough to treat item IDs as words in NLP and then just form a sequence of words or sequence of item IDs, because each item ID is associated with a value number. So you want to use both information at the same time. So how would you form a sequence of events, or how would you vectorize these information trying to use both information at the same time? How to use time. So timestamps are continuous values. So timestamps being chart time. So timestamps are continuous values. How would you use them when using RNN? So because there is no guarantee that the events would occur in a regular manner. Like, it's not like the events are always measured 1 minute after another minute, or 5 minutes after another 5 hours. Sometimes it's like measured, the time gap between events could be arbitrary. So how would you care to use that information, or would you just ignore that and treat them as a regular series, a regularly timestamped events? That's all. So it's just things to consider. These are not a must. It's something you might want to consider while building a classifier. What if two events happen at the same time? So there can be. So some events might happen at the same time. Some, like two separate item IDs, two different item IDs might have the same chart time. So in that case, what would you do? There can be two measurements at the same chart time. Then how would you treat them when you create a sequence input? That's another thing you might want to consider. Unknown feature values. For example, if your training data does not include some item ID, some specific item ID, let's call them item ID A, but your test data does. So it's like a out of vocabulary problem. Then how are you going to handle that? So there might be a lot more things to consider, but these are like the representative examples. All right, so this is a binary classifier, so you must have a label as well. So it labels. In this assignment, you don't need to care about subject ID. So we don't need to care about the identity of the patient. We don't even need to care about the identity. We need to care about the hospital admission ID, HADM ID. Because each ICU admission will be treated independently, and therefore you only need to care about ICU stay ID. So first, remove all ICU stays whose duration, this is the same thing. So we're filtering out the ones that we are not interested in. So filtering out less than 24 hour, more than 48 hours LOS. Then use the events from, so this is also all the same. All right, that's more challenging, yada, yada, yada. As for the mortality label, so once you've chosen your target, once you've chosen your target cohort, whose LOS is between 1 and 2 days, how are you going to, what information are you going to use to label the ones that are positive, ones that are negative? So go to the admissions table and look for, as for the mortality label, use the death time column of the admissions table. So let's go to admissions table. So in the admissions table, there are a lot of stuff, but there is something called death time. So death time is, what is death time? You go to, all right, here it is. All right, so so obviously this is admissions table. So this is about a single blue strip. This is about a single hospital stay, not the ICU stay. So this is blue strip level information. So admission, discharge, death time. Let's take a look at what they are. Admission time, admit time provides a date and time when the patient was admitted to the hospital, the blue strip, while discharge time provides a date and time the patient was discharged from the hospital. Okay, so these are like hospital level information. If applicable, death time provides the time of in-hospital death for the patient. So that means if the patient died during the hospital stay, not necessarily ICU stay, during the blue, so if the patient died within the blue strip, then death time is not null. If the patient didn't die and just successfully was discharged from the hospital, then the death time would be null for that patient. So we are interested. So we are interested in this column, death time. And note that death time is only so again, death time is only present if the patient died in hospital and is almost always the same as the patient's discharge time. Obviously, this is true because if the patient died, then patient is automatically discharged. No reason to stay longer in the hospital. All right, so we want to look at death time. So going back to the labels. So what you should do, you can imagine what you should do. So once you've chosen patients or ICU stays whose length of stay is 24 hours and 48 hours, you know whose admission ID that is, because if you go to ICU stay, there's also a hospital HADM ID, hospital admission ID as well. So you can go to hospital, you can go to the admissions table and match that individual ICU stay ID with hospital stay ID, and then link that information here by using this foreign key, and then check whether there is a death time or not, whether the death time is null or not. If the death time is null, it means that ICU stay ID did not end up with death. So it would be a negative label. But if the death time is not null and the death time is located between that 24 and 48 hours event, 48 hours window of the ICU stay, then that ICU stay is a positive label. Is that clear? Can you imagine how you should handle that? Basically, you need to join these two tables. So the ICU stays and the admission stay. You need to look at both tables at the same time and try to decide whether a single ICU stay is a positive label or a negative label. All right, so that's the labels part. And obviously, you want to split the data into training set and test set. So ICU admissions, so we'll test the data based on the ICU stay ID. So if the ICU stay ID, which is an integer, ends with the digit 8 and 9, they should be left out as a test set. So any ICU stay ID that ends with 1, 2, 3, 4, 5, 6, 7, 7, they are part of a training set, part of the training set. And any ICU stay ID who ends with 8 or 9 is part of test set. So that's how you should split. Questions from 현진님, 황현진님. 사망 여부만 주고 사망 시간 중요하지 않으면 테스트 타임이 아니라 hospital expire flag을 사용하면 안 될까요? 그게 그러니까 한 사람이 ICU 스테이를 여러 번 가져갈 수 있잖아요. 그리고 그리고 데스 타임도 이게 반드시 ICU 스테이 중에 죽으라는 법이 없거든요. 그러니까 이 블루 스트립 내에 레드 스트립이 여러 개 있는데 레드 스트립 사이에도 이벤트가 발생할 수 있잖아요. 그러니까 이제 ICU에 들어갔다가 나와서 쉬다가 다시 ICU에 들어가는데 그 쉬는 도중에도 사망을 할 수가 있고, 그렇기 때문에 우리는 분명히 우리의 타겟 타임인 24시간에서 48시간 내에 죽은 사람만이 포지티브 레이블이 된단 말이에요. 그렇기 때문에 데스 타임이 중요합니다. 그리고 이번 ICU 스테이가 여러 번 있을 때는 이번 ICU 스테이에서는 안 죽었을 수도 있지만 다음번 ICU 스테이에서 죽을 수도 있거든요. 그렇기 때문에 데스 타임을 보시고 포지티브 레이블 여부를 결정을 하셔야 돼요. 그렇죠. 맞습니다. 상황 예측은 ICU 28시간, 네, 정확히 그겁니다. 네. Alright, so data split is pretty straightforward, and so you need to have how many? You need to have 6, 1, 1, 1, 2, 3, 4, 5, 6 files that you need to generate after the pre-process steps. So 2 are used for training, training and testing logistic regression classifier. 2 are used for training and testing RNN GRU classifier, and these 2 are the label files. So obviously ytrain.npy would be used for training both logistic regression and the GRU classifier. Ytest would be used for testing and evaluation only. So these are all examples. So you can so the feature files, these are feature files, X that starts with X, capital letter X. So these are feature files. So how you would prepare your feature files is up to you. So it's just remember that these are just examples. So typically what I would do is prepare prepare these as a matrix, so n by m matrix, where the n is the number of trained or test samples, m is the number of features, obviously because we're training a logistic regression classifier. No need to care about the chart time, because we need to somehow logistic regression is not a sequence model, so you need to somehow aggregate all the events that happen within the first 3 hours into a fixed size vector or fixed size features. What if there are duplicate item IDs? So what if blood pressure was measured 3 times within the first 3 hours? How would you do that? How would you handle that in order to make a fixed size vector? So you could either use the most recent value only, or you could average all the values. That's up to you. I would use NumPy format to store these into a file. You could use you could just completely dump the NumPy object as a file. But note that this is only an example. You can use other features. You can use you can store them in any other format. You don't have to use NumPy, whatever. This is totally up to you. Same goes with RNN. So you have to prepare train features and test features. What I would do is I would store them in a text file of n rows, where n is the number of train or test samples. So it's a text, not a NumPy file. And each row contains a sequence of these chunks. So a chunk is divided into 3 parts: timestamp, item ID, and value. So I would convert chart time to timestamps such that the first timestamps are always 0 and they're incremented by minutes. So if you look at chart time is just a year, month, a day, and hour, minute, seconds. That's chart time. Actually, let me show you what chart time looks like. So yeah, look at, if you go to, okay, right. Look at the chart time here. So that is 1, 2, 3, 4, 5, 6th column. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6th column. So 6th column. This is chart time, and you can see that it is it's a datetime format basically, and I would convert them into, like, I would just normalize them normalize them so that the very first chart event, or the very first chart time would be 0, and then after that, the subsequent events would be incremented in the minutes, by the minutes. What happened to my... All right, I'm going to mute everybody. All right, so yeah, okay, so you can look at you can see that the seconds are never recorded. It's the highest resolution is by the minutes. So you can see that the seconds are always 0, like 0 seconds, 0 seconds. So you don't need to care about the seconds anyway. So that is why I said that resume share. That is why I said that increments are by minutes, because chart time does not use seconds anyway. So this is what I would do. Pre-process the chart events table so that each ICU stay ID would have a sequence of this chunks, where the chunks are divided into 3 parts: timestamp, item ID, and value. So example would be like a single ICU stay ID would look like this. So this means that the very first event happens at 0 minutes, and the item ID is this, and the value is this. And at the same time, another item ID occurred at the same time in the very first hour, in the very first minute, and its value was something. And then 30 minutes later, this happened with value this. And 60 minutes later, value item ID and value. 60 minutes after, item ID and value. Something like that. So it would be a sequence of text. But this, again, this is just an example. You can do whatever you want to form, to construct whatever features that whatever feature format you prefer to train RNN. This is up to you. This is an exception. So this is not up to you. This has to be stored in a very specific format, which is a NumPy vector. So this is a label. So it's a label for train samples and a label for test samples, and it must be stored in a NumPy vector, which means it's a one-dimensional matrix whose values are binary. So it's that 1 means death during ICU, 0 means no death during ICU. So it's a binary label. And you must use NumPy float format to store these 2 files. And the reason for this restriction is because in order to confirm that you have pre-processed data set correctly. So this will be used for evaluation, whether you've done your pre-processing step correctly. In order to confirm that you've done this correctly, we will check the number of positive, negative labels in both Y-train NPY and Y-test NPY. So this will be used for evaluation. So you make sure you store them in NumPy float array. All these are up to you, because this will be used by your training. This will be used by your classifier, logistic regression or RNN classifier. So, but this will be used. We will run a script using on top of these 2 files to evaluate whether you've done a good job or not on pre-processing. So make sure that you follow this instruction to the letter.
All right, and then moving on to the next part. So modeling evaluation. So when implementing logistic regression, you should use like scikit-learn because it's already there. So just, you can use logistic regression and scikit-learn to train a logistic regression classifier. PyTorch, you should use PyTorch GRU to train an RNN classifier. So please stick to this. Unless you have a really like absolute reason not to, please stick to this guideline. Use scikit-learn to implement this. Use PyTorch to implement GRU, and so that the TAs would have easier time evaluating and grading your submissions. And recommended use Python, use torch.nm.embedding to handle the embedding part. So this is just a recommendation. You can do whatever you want. 2 measures are to be reported by yourself. So you will use AURC and AUPRC as the evaluation metric, and you must use sklearn metrics AROC AUC and sklearn metric average precision score. So these 2 are already there, so they can just simply call them. So you can load these, and these inside your code, and then you would have your predicted outcomes. And then once you have those 2, the true labels and the predicted labels, you can simply call this or this to measure the AUPRC and AUROC and AUPRC. All right, what to submit. So this is the final. This is the last part. What to submit. So you should submit NumPy files, the files that you must generate the features and the labels you must generate after the pre-processing step. So 1, 2, 3, 4, 5, 6. So 6 files you must submit, and these 2 must follow the specs that we laid out right like in a few minutes ago, which is NumPy float format. These files should be located in the same directory as other files. Do not make any subdirectories. So when you submit your file, so you're obviously you're going to zip it, or you're going to compress it into a zip, like some zip format. And while doing so, please don't make any subdirectories. All the files should be located in a single location. 변영진님 질문 있으신 구현시 assertion을 위해서 train data split n 값을 가이드 주실 수 있을까요? 아니요, 그것이 evaluation 그 기준이에요. n 값이. 그러니까 트레인에 몇 명 들어가고 테스트 몇 명 들어가고 그 와중에 1이 몇 명이고 0이 몇 명인지가 그 평가 기준입니다. And the model parameters, so you should, so these 6 files you should submit, and you should also submit model parameters. So you should save your trained model parameters and then submit them along with other files. So logistic regression weights, you should extract them from your scikit-learn model, and then you should store them so that you should store them, and then you should write the code to load them to do the inference. And you should do the same with the GRU implemented in PyTorch. So train model parameters for logistic regression RNN models. These parameters, or these model weights, will be used in the test codes described below. So test codes, this is the test codes. Make sure you submit both logistic regression RNN model parameters. These files should be located in the same directory. So as I said, everything should be located in the same place. Do not make any subdirectories. And what you should, for testing or evaluating logistic regression, you should write a code. So write a code to evaluate the logistic regression classifier. These 3 files, so xtrain logistic, xtest logistic, ytrain NPY, ytest NPYs, will be used by this test file. Command must be Python, call this file Python test logistic regression, and there should be no arguments. There should be no user given arguments. This is it. So the TAs would only execute this command, and loading these 4 files and loading the model parameter should be done within the code. You should hard code them inside this script, Python script. So load your data set, your model parameters inside your code using a relative path. And your code should generate a file named like this. So student ID logistic regression.txt. So if this is your student ID, then this would be your output file. And in your current directory, so again, do not make any subdirectories. In your current directory that has student ID, train AURC, train AUPRC, test AURC, test AUPRC in order. So like exactly like this. So your file, this text file should have 5 lines, and it should start with your student ID, train AURC, train AUPRC, test AURC, test AUPRC, and that's it. So it should only print out 5 lines, and that's it. So the TAs should be able to, so the specs are the TAs will only execute this and expect this file to be generated, and the file content must be this. So all the others must be done by yourself. So write a code that does this automatically. Same for the test RNN.py. So this is for test logistic regression.py. There should be obviously test RNN.py, and code to evaluate RNN classifier, the GRU classifier, and these 4 files will be used. So train RNN, test RNN. So I mean, X train RNN, X test RNN, Y train RNN, Y test RNN. They should be used. They will be used in this code. Command is the same. So Python test RNN, all the and no arguments, and everything should be done automatically. So, and the output file is again test student ID RNN text, like just like this, and there should be 5 lines just like this. So that is the spec. And then zip all files into student ID tarball gunzip, and then when unzipped, actually, yeah, I'll just rephrase. But so you should submit the files such that you pack all these, everything, the NumPy files, the model parameters, test logistic regression.py, test RNN.py. You should pack them into single tarball gunzip with your student ID being the file name, and such that the folder name should be, yeah. Oh, and yeah, and when unzip the tar file, the folder name should be your student ID. So when we unzip this file, there should be a single folder whose folder name is your student ID. Okay, and then within that folder, everything should be inside that folder. So all these files, all these NumPy files, model parameters, test logistic regression, test RNN, they should all be inside that folder whose folder name is your student ID. So that's it. Hope this is clear. All right, so assignment evaluation. So the grading schemes are like this. So if you submit all codes and all files, you're given 5 points. If you correctly pre-process Mimic3, which is based on the ytrain.npy and ytest.npy, if you've successfully pre-processed the Mimic3, then you're given 10 points. If your both models, logistic and GRU, shows reasonable performance, that's 15 points. And if your models outperform TA's model, then you're given 20 points. All right, so that's it. So, and there are no late submissions. And if you have any question, you can address them to, you can direct your questions to the TAs. Question. So 교수님 테스트 로지스틱을 실행심 저장도 모두 리뷰레이션만 하는 게 아닌 저 저장 하이퍼파라이팅 값을 불러서 트레인. 아니요, 트레이닝 하는 거 아닙니다. 트레인 하는 거 아니에요. 아니요, 트레인 하는 거 아닙니다. 그냥 이미 트레인 된 모델의 파라미터를 알아서 불러가지고 거기서 그냥 결과만 쭉 뽑는 거예요. 그러니까 이미 트레인된 모델을 가지고 트레이닝 샘플 다 돌려서 프리딕션 뽑고 그 프리딕션 된 값을 Y트레인 넘파이랑 비교해서 AURC랑 AUPRC 계산할 수 있잖아요. 그리고 똑같이 이미 트레인된 모델 로딩 해가지고 테스트 피처들 쫙 돌려가지고 프리딕션 아웃컴 쫙 뽑을 수 있잖아요. 그거랑 또 Y 테스트 레이블이랑 비교해서 AURC랑 AUPRC 뽑고 이렇게 하는 겁니다. 그러니까 학습 다시 하는 거 아니에요. 네. 네네, 맞습니다. 네. 모델 크기 제한은 없는데요. 이거 뭐 굳이 크게 하실 필요 없습니다. 이거 뭐 그렇게 뭐 어려운 태스크, 뭐라 그럴까, 태스크 자체는 어려운데, 왜냐하면 3시간치의 정보만 보고 사망 예측하는 거니까 태스크 자체는 어렵지만 이게 컴퓨테이셔널리 보면 그렇게 어려운 태스크가 아니기 때문에 뭐 모델 크게 하실 필요 없을 거예요. 그냥 싱글 레이어짜리 뭐 256 히든 레이어 이 정도만 해도 괜찮을 겁니다. What is the performance of TA model? I think the TAs are working on it, so we should be able to share the kind of like the TA performance on Classum maybe next week or so. 테스트 오버핏된 모델 셀렉션이 아닌지 확인하시는지. 테스트 오버핏된 모델. 그 테스트 셋에 대해서 오버핏 했냐 안 했냐. 글쎄요, 테스트에 대해서 오버핏을 하셔도 뭐 확인할 방법 없는데, 그게 너무 높으면 문제가 있겠죠. 지금 그러니까 TA 분들은 오버피팅 안 하고 그냥 적당하게 이제 테스트 트레이닝 셋에 대해서 학습한 다음에 테스트 셋에 대해서 한 번만 이밸류에이션 하실 텐데, 그 성능이 예를 들어서 뭐 15% AUPR식 15가 0.15가 나왔다. 근데 제출하신 게 뭐 99가 나왔다. 이런 문제가 있겠죠. 그건 저희가 적당하게 판단을 하겠습니다. When is the due date? Due date. Actually, yeah, I forgot to share the due date. So the due date is so today is Thursday. So I'm thinking about giving 2 weeks, which is April 8th of April. 8th of April. Yeah, I'll post them on Classroom as well. So everybody will be given 2 weeks to finish this project. Hopefully, if you closely followed the lectures, then you will be able to do this within a day or two. The most amount of time would be spent on pre-processing, actually, and pre-processing, going through the chart events. That would take up most of your time. Actually, training the classifiers is like less. It won't take even like couple of. It won't take like maybe 6 hours or so. Yeah, it's a pretty quick job. 개인이 제출한 X테스트 MPY가 아닌 모두가 동일한 X테스트 MPY로. 아니요, 개인이 제출한 걸로 당연히 개인이 제출한 Y인가요? X인가요? 이게 X테스트라는 게. 그러니까 피처는 당연히 개인이 제출한 걸로 되겠죠. 네, 제가 참 질문을 이해를 못했는데, 그러니까 X 트레인 R는 X 테스트 R는 X 트레인 로지스틱, X 테스트 로지스틱 이거를 가지고 채점을 합니다. 근데 채점을 하기 전에 애초에 Y 트레인이랑 Y 테스트가 맞아야지 채점을 할 수가 있어요. 그러니까 프리 프로세싱이 제대로 안 됐으면 그 다음 스텝을 넘어가지 않아요. 이제 10점을 받으셔야지 15점을 받을 수가 있는 거예요. 네. 학습하실 때 언더 샘플링, 오버 샘플링 하셔도 괜찮습니다. 그거는 그러니까 근데 그러니까 이제 Y 테스트랑 Y 트레인이 맞기만 하면은 그 안에서 코드에서는 뭐 언더 샘플링 하시든 오버 샘플링 하시든 그건 적절하게 하셔도 됩니다. 네, 그리고 당연히 굉장히 클래스 임밸런스가 있을 거예요. 네, 그리고 하나 중요한 거는 요거 다 제출하실 때 이름을 정확하게 맞춰주셔야 돼요. 이 파일 이름들. So important thing is the file names must be exactly met. So please respect the file names to the letter. So this, the capital letters and all that, it must be exactly the same. Model parameters, it's up to you because we will not be touching the model parameters anyway. And these should be exactly the same as well. So test logistic regression.py, test rn.py, please use the name of the files exactly like this, so that the TAs wouldn't have trouble evaluating the submitted files. So in the beginning, in the first day of the class, first day of the course, I said that if you are interested there are two options for doing the future projects. One is just following the ones that we've prepared, and another is proposing your own topic. And I would say getting 15 points is a reasonable requirement for proposing your own project topic. Unless you can get 15 points, it means that you're not really ready to do your own healthcare project. So if you're interested in doing a project of your own, instead of doing projects that we've prepared, please try to get 15 points. 데이터 스플릿의 개수는 맞아야 하지만 포함시킨 피처는 네, 그렇죠. 당연하죠. 포함시킨 피처 개수 모두 다를 수 있습니다. 네. 그렇기 때문에 저희는 이 피처를 가지고 뭔가 이밸류에이션 할 건 아니에요. 이거는 안 할 거고 이 두 개만 보고서 과연 프리 프로세싱을 잘했는지 안 했는지를 채점을 할 겁니다. 전 처리 후 탄생한 입력 데이터 디멘전 크기도 디자인 파람 네, 그러니까 알아서 하시면 됩니다. 그것도. 그 말은 지금 몇 개의 피처를 쓸 거냐 뭐 이런 얘기이신 것 같은데 로지스틱 리그레션의 경우 몇 개의 피처를 쓸 거냐 이거 말씀하시는 것 같은데 그거는 네, 그 스스로 정하시면 됩니다. 그러니까 차트 이벤트에서 아이템 아이디를 설정하실 때도 모든 아이템 아이디를 다 쓰실 수도 있지만 그냥 나는 그런 거 다 관심이고 나는 그냥 뭐 혈압만 관심 있다 그러면 그냥 딱 몇 개 아이템 아이디만 특정해가지고 그것만 뽑으시면 돼요. 그러면 훨씬 더 간단한 클래시파이어가 탄생하겠죠. 그러니까 뭐 시스톨릭 블러드 프레셔, 다이어스톨릭 블러드 프레셔, 민 블러드 프레셔 딱 세 개. 나는 그 세 개만 관심 있다고 해서 쭉 계속 차트 이벤트 훑으시면서 나머지 아이템 아이디 다 버리고 그 세 개만 가지고도 뭐 피처를 구성하실 수도 있고 그냥 나는 뭐 그런 거 모르겠으니까 나는 발생하는 거 모든 거 다 그냥 가져다 쓸 거다 하실 수도 있을 테고 그거는 알아서 하시면 됩니다. 그리고 밸류 넘버가 널 값인 아이템 아이디도 가끔 있거든요. 그런 경우 걔네는 버리든가 아니면 밸류 넘버를 뭐 그냥 0으로 세팅하고 넣으시던가 그것도 알아서 하시면 됩니다. So I just said that sometimes some item IDs might have value number as null because some item IDs are can only be measured by qualitatively. Like for example, like some lab tests or some procedure might have outcome like normal or abnormal. So the string value would be like normal at normal, and the value num would be null. So in that case, you might want to discard that item ID, or you might want to just still use the item ID but without any value number, or maybe set the value number to -1 or something. It's up to you as well. 형진, 이번 과제 질문 아닌데 ICU 스테이와 어드미션 연결할 수 있으면 여러 어드미션에서 ICU 스테이도 같은 사람에게라고 연결할 수 있지 않은가요? 여러 어드미션에서의 ICU 스테이도? 이게 무슨 뜻일까요? 여러 어드미션에서 ICU 스테이도 같은 사람에 연결할 수 있지 않은가요? 아마 제가 그 미믹스리랑 EICU 차이를 설명드릴 때를 말씀하시는 것 같은데, 그러니까 미믹스리 같은 경우는 한 사람이 그 병원에 방문한 그 오더를 알 수가 있거든요. 그 이제 예를 들어서 한 사람이라는 거 이제 뭐 주민등록번호를 특정을 한다 그러면 어떤 특정 주민등록번호를 이용해서 그 사람이 병원에 그러니까 ICU가 아니라 병원에 일단 입장을 해야지 ICU에 들어가는 거니까 그 블루 스트립을 말하는 건데 그 블루 바를 말하는 건데 그 블루 바가 언제 생겼는지를 알 수가 있어요. 그래서 한 사람이 언제 병원에 그러니까 이제 블루 스트립 블루 바들의 순서를 알 수가 있거든요. 그러니까 어떤 사람이 언제 병원에 방문해서 그 안에서 뭐 언제 ICU를 들어가려고 했다. 그 다음에 병원에 퇴원해가지고 다음번에 또 언제 뭐 몇 달 후에 또 몇 년 후에 또 병원에 방문해서 또 어떤 ICU 들어가려고 했다. 미믹스리론 이게 가능한데 EICU는 그게 불가능한 게 EICU는 한 사람이 병원에 여러 번 방문한 것까지는 알 수가 있어요. 이 사람이 병원에 3번 방문했다. 그러니까 ICU가 아니에요. 병원이에요. 지금 블루스트림 얘기하는 건데 병원에 뭐 4번 방문했다, 5번 방문했다 알 수가 있는데 순서를 알 수가 없어요. 순서가. 이 사람이 언제 방문하고 그 다음에 언제 방문하고 이걸 모르고 그냥 이 사람이 방문했다라는 것만 알 수가 있어서 한 사람 전체 인생에 걸쳐서 병원 방문을 쭉 기록을 하면서 어떤 시퀀셜 오더를 가지고 뭐 이렇게 모델링하고 그런 게 안 돼요. EICU는. 그게 불가능합니다. 미믹은 그게 가능한데. 그 얘기 하시는 것 같은데요. 네, 그래서 ICU 스테이는 병원 방문 내에서 일어나는 일이니까 무조건 순서를 알 수가 있어요. 그 EICU든 미믹스리든. 네. 승우님, 네. 결국 청취할 때 저희가 한천천히 과정을 그대로 TA님들로 갖고 계신 되게 프라이빗 데이터 놓고. TA 분들도 자기 자신이 스스로 전처리한 데이터들이 있겠죠. 근데 이제 그걸 이용해서 측정하진 않습니다. TA 분들 걸로 이제 끝나고 이제 여러분들이 제출하는 걸 가지고만 성능 측정을 할 건데 애초에 성능 측정을 하기 전에 ytrain.npi랑 ytest.npi를 보고 걔네를 이제 로딩을 해서 거기에 숫자랑 1, 0 개수를 세 가지고 그게 맞아야지 이제 성능 측정을 하는 겁니다. 그러니까 스플릿한 데이터는 똑같아야 돼요, 당연히. 왜냐하면 우리는 전부 다 ICU 스테이 아이디가 8이나 9로 끝나면 테스트고 1, 2, 3, 4, 5, 6, 7로 끝나면 트레인이라 그랬잖아요. 그러니까 스플릿이 정확하게 똑같아야 됩니다. 그리고 총 ICU 스테이 아이디 개수 똑같아야죠. 왜냐면 우리는 지금 24시간, 48시간 입원한 사람만 대상으로 하기로 했기 때문에 그것만으로도 이미 모든 사람이 같은 ICU 스테이 아이디를 공유하고 있어야 되거든요. 그러니까 거기서 거기서 이제 컨퓨전 일어날 그게 없죠. 네, 랜덤 스플릿 아니에요. 랜덤 스플릿 아니 큰일 나십니다. 랜덤 스플릿 아니고 여기 써 있는 그대로 디짓 8, 9로 끝나는 것이 테스트고 디짓 1, 2, 3, 4, 5, 6, 7로 끝나는 게 트레인이에요. 이거 you must use please go through this spec line by line so you have like as little confusion as possible. I hope that there is actually no confusion because we've spent a lot of time preparing this spec. Another thing to keep in mind, this is less or equal to. So exactly 24-hour is okay. 23.999 hour is not okay. 24.0 hour is okay. 48 hour is okay. So please keep, this less or equal to is important because there might be some cases who has been in the hospital, who has been in the ICU exactly 2 days. So 요거는 점수는 15점 만점인데 5점을 세이브했다가 나중에 혹시 다른 데서 이게 다른 데서 그러니까 다음번 프로젝트 2나 3에서 이제 미진하면 그때 그 5점을 갖다 쓰시면 됩니다. 그런 개념이라고 보시면 돼요. 그냥 5점 세이브해놓고 나중에 쓰시는 겁니다. 준우님, 혹시 트레인과 테스트 숫자와 같은 메타 정보 알려주시나 천천히만. 네, 그걸 아는 게 이 문제의 핵심이에요, 사실. 네. 그러니까 사실 트레이닝과 테스트하는 거는 굉장히 쉽고 이거를 애초에 그러니까 지금 이 훈련을 하는 이유가 여러분들이 엠니스트나 무슨 있죠 또 WMT나 이런 이미 잘 정제된 데이터셋만 가지고 보통 이 뉴럴넷을 그 기계학습 이제 공부를 하시잖아요. 근데 실제로 현장에 나가면 그럴 일이 거의 없어요. 실제로 현장에 나가면은 직접 이 트레이닝셋 테스트셋을 직접 만들어야 되거든요. 로 데이터로부터 직접 하셔야 돼요. 어디요, 취직을 하시든 구글에 가시든 어딜 가시든 그냥 수없이 많은 데이터, 구글이 가진 데이터가 얼마나 많겠어요. 페이스북이 가진 데이터가 얼마나 많겠어요. 근데 그 데이터로부터 일부를 뽑아가지고 그거 정제해서 트레이닝셋 테스트 만들고 학습까지 해야 되거든요. 학습하는 건 정말 이 빙산의 조각일 뿐이에요. 그래서 그거를 하는 과정입니다, 이게. 그래서 프리프로세싱을 잘했는지 못했는지가 이거의 핵심이에요, 사실. 개수의 실수가 있으면은 사실은 그건 이제 저희가 아직 크게 정하지 않았는데 한두 개 틀렸다. 그런 경우가 있을 수 있을지 모르겠어요. 한두 개 틀리는 경우가 있을 수 있을까요? 코드를 잘못 짰는데? 틀리면 아예 틀리는 거고 맞으면 아예 맞는 거지. 지금 이게 그 의문의 여지가 아예 없잖아요. 그러니까 LOS가 1.0에서 2.0 사이인 애들만 뽑아가지고 하면 되는데 그게 과연 실수의 여지가 있는지 모르겠어요, 저는. 레이블은 혹시 레이블의 개수는 틀릴 수도 있겠죠. 근데 적어도 N수는 무조건 맞아야겠죠. 현진님, 방금 전에 말씀하신 23.99시간에서 아니 23.99시간이 포함이 안 돼야 되죠. 왜냐하면 한 1데이 이전이니까 48.05시간도 그렇죠. 48.05시간도 포함이 안 돼야죠. 왜냐하면 2데이 이상이니까 2데이 초과니까. 네, 그 얘기입니다. 혹시 기존 트레인에서 노이즈 데이터 읽어지는 걸 더 걸러낸 상태에서 최종 트레인 NPY를 제출해도 되나요? 그러니까 X 트레인 로지스틱 리그레션 NPI랑 X 트레인 RNG NPY를 N수를 조절해도 되냐 이 말씀이신가요? 네. 그렇게 되면은 Y 트레인이랑 Y 테스트랑 안 맞을 텐데요, 개수가. 네, 그러면 당연히 이밸류에이션 제대로 안 되죠. 저희가 이밸류에이션 돌릴 때. 네, 그래서 무조건 n수는 맞아야겠습니다. 네. Alright, so 코드를 로직을 네, 뭐 그렇게 하셔도 되고요. 네, 뭐 그렇게 하셔도 됩니다. 그러니까 뭐 학습하실 때는 뭐 적은 개수를 학습을 하시지만 적어도 평가를 돌릴 때는 Y 테스트에 있는 거랑 Y 트레인 있는 걸 제대로 쓰셔야 돼요. 평가를 하실 때는. 학습하실 때는 덜 쓰셔도 되지만. 네, 어쨌든 최종적인 아웃풋이 이 5줄이 나와야 된다입니다. 네. 뭔가 하나 말씀드리려고 했는데 뭐기 하려고 했더라? I was going to say something. I forgot what I was going to say. Oh yeah. Okay. So important thing is, please submit anything. Just the files. Like they could be even empty files. Like just please submit all these, these six files and 2 model parameters and these 1, 2 scripts today on KLMS so that you at least get 5 points. Some people don't even meet the deadline. So please just submit empty files that only follows the specs on the surface level. This could be empty file. This can also be an empty file. Model parameters can be empty as well, and these can all be empty. But please at least submit the file so you get at least 5 points. 5 points is better than 0 points because 0 points is like it's equivalent to just not submitting at all. So that's equivalent to just getting F. So please submit something today so that there is no late submissions from anybody. So you will start with 5 points, and 5 points is as good as, in my estimation, like B or something. So please just submit anything. We won't. Yeah, it doesn't even need to be runnable because runnable means it's like 15 points actually. So just submit anything. If you don't intend to do this project, that's totally fine. It's up to you. But at least submit something so you get 5 points at least. So that will be your like lower bound score. 네, 맞습니다. 압축계시 디렉토리 스트럭처랑 그 안에 있는 파일만 맞아도 5점이에요. 아무것도 안 내신 것보다 5점이라도 가져가세요, 제발. 그래야지 저희가 이거를 F를 안 드리니까. 그러니까 압축 요거 안에 폴더가 하나가 이걸 압축해야지 하면 폴더가 나오고 그 폴더 안에 이거 모델 파라미터 이 6개만 있어도 이미 5점 시작이에요. 네, 그것조차 안 지키신 분이 제발 없으시길 바랍니다. Alright, so are there any more questions? 여덟 개 이상일 것 같은데 지금 6개에다가 모델 파라미터 2개면 8개고 그 다음 얘까지 하면 10개죠. 네. Alright, if there are no more questions, this is the end of the class today. And so we are interested in 3 tables. That is the minimum requirement. You can use more tables and more features if you want to, but those three are absolute minimum requirements in order to actually even construct the data set. Yep. All right. I'll share the link to this document, this Google Doc on Classroom after this class, so that you can refer back to this as many times as you want. And as always, if you have questions, you can post them on Classroom. All right. Yeah, that's the end of the class today. And oh, by the way, so next week is more or less it's like a project week. So there's no class, but I will be here on Tuesday to answer any question that might arise while doing this project. So the next week will be more or less just the question answering sessions. So please try to do this task as soon as possible, so you have something to ask. If you have something to ask, just ask away as early as possible. Because starting from the week after next week, so starting from 2 weeks later, we'll resume our usual schedule and go with like more advanced models, like interpretable models or domain knowledge models. So we won't have time to discuss the specs or the problems from the projects anymore. So if you please use next week as your chance to ask questions. All right. All right. Good luck, everybody, and have a good weekend. And I'll see you guys next Tuesday. Bye-bye.